Hi everyone, here I am very much excited to share my internship experience in an embedded system. In this presentation, I will explain what embedded systems are, their types, main components and the microcontrollers I worked with. I will also explain the practical concept I learned such as keypad interfacing, LCD interfacing, interrupts, timers and communication protocols. Finally, I will present my project titled Microwave Oven Control System and explain its working modes and feature scopes. Let's come. Let's questions comes in our mind. What are the embedded systems? An embedded system is a specialized computer system that is designed to perform a specific task or functions. Unlike a personal computer which can perform many tasks, an embedded system is designed to do only one job. These systems are usually part of the larger systems. For example, washing machines, microwave oven, and car contains embedded systems inside them. Embedded systems are designed to be very reliable, low power consuming, and fast. Many embedded systems work in a real time, meaning they must respond immediately to the inputs. They are widely used in automobiles, medical devices, consumer electronics, and industrial machines. The characteristics of embedded systems are embedded systems have some special characteristics. They are small in size and consume very less power. They are designed to run continuously without failure. They usually work in a real time, which means they must respond within a fixed time. They are also cost effective and optimized for a single application. Categories of embedded systems. In embedded systems are classified into different types based on the how they work. First one is standalone embedded system. It works independently without any external connections, for example, microwave, oven, and calculator. Second one is real-time embedded system. It must respond within a specific time, for example, airbags in the cars and medical monitoring systems. Third one is networked embedded systems. These embedded systems are connected through a network or internet, for example, IoT devices and smart home systems. Final one is mobile embedded systems. These are portable and battery operated, such as smartphones, smartwatches, and digital cameras. What are the components of the embedded systems? In embedded systems is made up of several important components. The microcontroller or microprocessor is the brain of the embedded system. It controls all the operations. Memory is used to store the program and the data. Input devices like switches, sensors, and keypads are used to give commands. The output devices like LCDs, LEDs, motors, and buzzers display or perform actions. Power supply provides energy and clock. Circuits maintain synchronization. Communication interfaces like UART, SPI, and I2C help in a data exchange between devices. Next, microcontroller. What is a microcontroller? Microcontroller is a small computer integrated on a single chip. It contains a CPU, memory, input-output ports, timers, and communication modules. It is mainly used for controlling devices automatically without human intervention. The microcontrollers are used in washing machines, traffic lights, medical equipment, and industrial machines. Some popular microcontrollers are PIC AVR, ARM Cortex, and ESP32. Block diagram of the microcontroller. This is the internal structure of the microcontroller. The CPU is responsible for processing the instruction. The memory stores the program code and variables. Input-output ports connect the external devices. Timers helps in time delay generation. Communication models help in data transfer between devices. MPLAB, IDE, and development environment. The MPLAB IDE is a software tool used for writing, compiling, and debugging programs for PIC microcontrollers. X8 compiler, which compiles convert our C code into a machine code. PICSimLab is used for a simulation. This is a simulation where we can test our project without hardware. These tools makes development easier and help in finding the error before real implementation. In that internship, I worked on PIC 16F877A microcontroller. The PIC 16F877A is an 8-bit microcontroller widely used in embedded applications. It has a 33 input-output pins, multiple timers, ADC, analog to digital converter, and communication modules like UART, SPI, and I2C. It is easy to program and suitable for beginners. It operates between 4 to 5.5 volt and support a maximum clock speed of 20 megahertz. Next, microcontroller peripherals utilization. In this internship, I worked with the different peripherals connected to the microcontroller. A LCD is used to display a message, time, and system status. Switches and keypads are used as a input devices to give a command to the system. Next, timers. The timers helps in generating accurate delays and managing a time-based operations. The buzzer is used to give a alert and notification to the users. These three peripherals makes the system interactive and user friendly. Next is ports and pins in node configuration. The PIX 16F877 has a 5 GPIO ports that are port A, port B, port C, port D and port E. These ports are used to connect external devices like LEDs, switches, sensors and displays and keypads. Each pins can be configured as either input or output using trace registers. Some pins can work as a digital or analog based on the configuration. This flexibility allows us to use the microcontroller for many applications. Next, tactile switches in embedded systems. The tactile switches are small push buttons that provides a clicking feel when pressed. When the button is pressed, it closes the circuit and sends a signal to the microcontroller. The microcontroller reads this signal and performs the required action. These switches are commonly used in remote controls and calculators and control panels. They are simple, reliable, easy to interface. The first one interfacing is a matrix keypad interfacing summary from the image. A matrix keypad consists of rows and columns arranged in a grid. When a key is pressed, specific row and column are connected. The microcontroller continuously scans the rows and columns to detect which key is pressed. This method reduces the number of pins required, and matrix keypad are used in ATMs, security systems and password based devices. Interrupts in embedded systems. Interrupts allow the microcontroller to respond immediately to the important events. Instead of continuously checking for an event, the microcontroller can perform other tasks. When an interrupt occurs, the normal program stops and an ISR is executed. External interrupts come from switches or sensors. Internal interrupts come from timers, ADC, communication models. Interrupts are very important in real-time systems. Timers in embedded systems. Timers are used to generate an accurate time delay. They can work in a timer mode or counter mode. In timer mode, they count internal clock pulses. In counter mode, they count external events. PIC 16F877 has a timer 0, timer 1 and timer 2. These are used in applications like motor speed control, blinking LEDs and a time countdown. The next one is LCD interfacing. LCD interfacing in an embedded systems. An LCD is used to display output information to the users. The most commonly used LCD is 16:2. It can be connected using 4-bit or 8-bit mode. In my project, I used 8-bit mode. The microcontroller sends command and data to the LCD. LCDs are used in devices like digital clocks, calculators and industrial panels. The key learnings from this internship. During this internship, I learned embedded C programming and I gained hands-on experience with hardware interfacing and I learned how to debug and fix errors. I understood how real-time embedded systems works. This internship helped me bridge the gap between theory and practical knowledge. Next, I2C communication. I2C communication. I2C is a real communication protocol that uses only two wires, SDA and SCL. SDA is used for data transfer and SCL is used for the clock synchronization. Each device on the I2C bus has a unique address. This allows multiple devices to communicate using the same wires. It is widely used in sensors and RTC models. At the end of this internship, I have built one project, that's microwave oven project. The overview of this project shows. This is a main project I worked on during this internship. The objective is to design a microcontroller based microwave oven control system. The system uses PIC16F877A as the controller. The keypad is used for the input and LCD is used to display the information. A fan and buzzer use and relays are used to control a high power device. The project hardware architecture shows here. The PIC microcontroller is the main control unit. The keypad is used to enter time and a mode. The LCD displays the selected mode and the remaining time. The relay controls the heating element. The fan helps in cooling. The buzzer gives alert. The door switches ensure safety. The working principle of this project is: first, user select the mode and enters the time using the keypad. The microcontroller processes this input and the time start counting down. The relay controls the heating process and the LCD displays the remaining time. When the time reaches to 0, the buzzer alerts the users. First one is micro mode. In micro mode, the system operates at a constant power. The user enters time in minutes or and in seconds. Timer interrupts decrement the time every second. The heating process continues until the timer becomes 0. This mode simulates normal microwave heating. The next mode is grill mode. In this grill mode, the heating element is used for grilling. The user sets the time and the relay turns on the heating element. The fan runs to distribute the heat evenly. The LCD shows grill mode and the remaining time. The third operational mode is conventional mode. In conventional mode, the system first preheats. The user sets the temperature. The preheat timer starts. After preheating, the user enters the cooking time. This mode simulates real convection oven. From this project, what are the future scopes and enhancement? This project can be improved further. IoT can be added for a remote control in using mobile apps. A touch screen can replace the keypad. We can use the AI. Can be used to automatically adjust cooking time and the temperature. And energy optimization. Power optimization can be done to reduce the energy consumption. As we all are discussed in a presentation, this is a MPLab compiler. This is my code file. In this contains, these are the header files. clcd.h, matrix keeper.h, microvan.h and a timer system. These all are the header files. And these all are the source files. clcd.c, isr.c, main.c, matrix keypad, microvan and timer.c. These all are the source files and these all are the header files. Now we need to clean and build the project. So next, clean and build the project. Clean and build. Yes, here shows the code is clean and build successfully. Here there is no error. Then we can leave it, ignore it. Next, the code is uploaded successfully. Now it's created the hex file. PICSimLab simulator. In this PICSimLab simulator, we have worked on PICGenius board and microcontroller used PIC16F877A. Here this is represent the LCD display, CLCD display, and this is a fan for cooler. This is a heater, and these two blocks are represent the two relays. And this is the matrix keypads. These are all the port D and port B LEDs. This is my main microcontroller, PIC16F877A. We need to upload the X file, load X file. Go to my X file is uploaded successfully. I start the LCD showing power on, and it shows the main 4 functions. This microwave oven project perform mainly 4 operations. This is a user interface. Next we have to choose the first one, micro mode. In this micro mode, it constantly power consuming 900 watt. Here the set time. We need to set the time for the cooking. The time I have set 50 second. This is represent the seconds. This is minutes. If you click the star button, it's clear everything what you already written this now. Let's check this one. Clear everything. Next, set the time. Enter the time 20 second. Enter. Then our fan is running on until the it comes to 0 second. This is starts and resume. If you click on the 4 keypad, it starts and resume. And if you want to stop this, you can directly click on the 6, and after it comes to 0, it tells your meal is ready. Next one is grill mode. In this grill mode, you have to set the time 30 seconds. It is also same like that. If you click on the 5, it paused the running of this process, and if you click on the 6, it stop the present execution of this project and go to the user main interface, menu of the interface. Let's enjoy your meal. Time out. Third one is convection mode. Click on the third. Here we have to set the temperature. I set 554 temperature Celsius. It is in degree Celsius. Enter. It is a preheating process. It take time 1 minute to heat. It's take 1 minute time to preheat the system. It's take 1 minute time to preheat process. What you have entered temperature using that. Let's you have to enter the time now. I enter 10 seconds. One second. So next fourth one is start. This is a default mode. Here it takes automatically. Here we no need to enter manually. That is my project I have built at the end of my internship. Thank you so much.